Hello, I'm Heather Knox.
And I'm Suzanne St. John.
And we're from Murfreesboro City Schools. Today, we are going to be using eggs to learn about science. We will be doing a few experiments with items that you most likely have in your home. So sit back, relax, and let's learn about eggs through some exciting experiments. Science is learning about our world through experimentation and observation. And asking questions is a huge part of learning about science. When we ask questions, we can design experiments to make observations of how our world works. So as we continue through this lesson, you will see that we're going to ask a lot of questions. We want you to think about how you would answer those questions yourself and come up with questions of your own. In fact, I have a question from a student right here, and they've written me a letter. The letter states, Dr. Knox, I've been thinking a lot about eggs. Don't you think eggs are extraordinary? I have so many questions about eggs. Maybe I need to find an eggspert. Where can I go to find out more about eggs? Sincerely, Susie. Well, Susie, I'm excited that you were asking questions about eggs, and there are a few ways that you can find out more information. One way is for you to go out into nature and look on your own. Go explore and see what eggs you can find. Take a journal with you, and when you do that, write down what you notice about them, where you find them, and what happens to them over time. Another way to learn about eggs is through text, and Miss St. John has a wonderful book about eggs that she would like to share with you.
As we read this book, I want you to think about what you notice about the eggs and what questions or connections you may have to the eggs as well. This book is called An Egg is Quiet by Diana Aston, illustrated by Sylvia Long. I think the cover is quite beautiful. An egg is quiet. It sits there under its mother's feathers, on top of its father's feet, buried beneath the sand, warm and cozy. An egg is colorful. There are so many different kinds of eggs on this page, and they all look different. An egg is shapely. There are round eggs and there are oval eggs. There are pointy eggs and there are even tubular eggs. Sea turtles dig a hole in the sand with their flippers and lay up to 200 soft, round eggs. Round eggs fit nicely together in tight spaces. A ladybug has oval eggs. When the ladybugs hatch as larvae, their first meal is often the egg case they crawled right out of. Seabird eggs are pointy at one end, so if they are laid on a rock, they roll around in safe little circles and don't fall off the cliff. While most sharks give birth to live young, some sharks, like the lesser spotted dogfish, begin life in a leathery case with tendrils. The tendrils anchor the eggs to the seaweed so they won't be swept away by the ocean current. An egg is clever. The markings on some eggs help them blend in with their surroundings. This is called camouflage. Camouflage is an egg's way of hiding. An egg might be speckled to resemble the rocks around it, or it might be gray, the color of the mud by the lake. An egg does not want to be eaten by a raccoon or a snake or a fox or an insect. Eggs come in different sizes. An ostrich egg can weigh as much as 8 pounds. It is so big and so round that it takes 2 hands to hold one egg. Hummingbird eggs are the size of a jelly bean. It would take about 2,000 hummingbird eggs to equal the size of one ostrich egg. An egg is artistic. They're colorful, they have different designs. An egg is textured. There are hard eggs and soft eggs and gooey eggs. There are smooth eggs and rough eggs. Bird eggs are hard. Reptile eggs are often soft and rubbery. Amphibian eggs are gooey. The goo keeps them from drying out. Most bird eggs are smooth. Eggs of cassowaries, emus, and cormorants are rough. An egg might even be fossilized. The remains of creatures that died millions of years ago may become rock hard or fossilized. Scientists have unearthed fossilized dinosaur eggs all around the world. Some are round, some are oblong. Some are as small as 1 inch across, and some are as large as 20 inches. Scientists believe all dinosaurs hatched from eggs. An egg is giving. An egg gives the little creature growing inside everything it needs. The shell is its home. The yolk is its food, and the egg white is its pillow. The shell is covered with teeny tiny holes which allow air to enter. An egg is quiet. Then suddenly, an egg is noisy. Peep, 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 cheep, 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 crunch, crunch. And there's all the creatures that have come out of the eggs. What did you notice about the eggs in the book? How are they the same? How are they different?
Well, I noticed that there are all different kinds of eggs. There are even eggs that I didn't even know were considered eggs. The eggs are the same because they are houses for the babies to grow. And they're different because they come in different colors, size, shapes, and textures.
So why do you think different eggs might be different colors?
Well, the book said camouflage. Camouflage is an organism's natural way. It's a coloring or form so it can hide in its environment. And that needs to hide itself from predators to keep itself safe, because there are predators out there that will go and eat eggs. There are predators such as the red fox and snakes and badgers that eat eggs. I know when I was on the farm, we had to keep snakes away from our eggs, and we had to check the hen house every morning to make sure that there wasn't a snake in there when we went to get the eggs. But wait a minute, I eat eggs too. So does that mean I'm a predator too?
You might be a predator. But what is important about the shape of an egg?
Well, there were 2 times when you were reading the book that I thought was really interesting about the shape of an egg that I learned something new. The first was when you talked about the shape of a seabird egg. Seabirds can lay their eggs on rocks and cliffs near the water. And the book stated that the seabird eggs were pointy at one end. And if they're pointy at one end, then they're on the rock, then they wouldn't roll off. They would just go in circles. So that's kind of a protective way to make sure that the eggs don't crack. The second time that I heard in the book that it mentioned how the shape was important was when you were talking about the lesser spotted dogfish eggs and how they were tubular-like and had tendrils on them. And those tendrils attached to seaweed to anchor them so they wouldn't go away. I wonder if there are other organisms out there that lay eggs and the shape of their eggs helps protect those. Maybe some of our students will look that up for us and report back to us and let us know about that.
Well, I think that's important. Another thing, why do you think the eggs would be different sizes?
Well, in the text you read about 2 different size eggs. You read about hummingbird eggs and ostrich eggs. You said that hummingbird eggs were about the size of a jelly bean and ostrich eggs were about 2,000 times bigger than that. So if I think about what I know about hummingbirds, they're pretty small. And if I think about what I know about ostriches, they're pretty big. I would say the size of the egg has something to do with the size of the adult.
Well, I know this wasn't discussed in the book, but why do you think that an egg doesn't break when a bird sits on it?
That's a really great question. Do you think there's a way that we could find that out of why an egg doesn't break when a bird sits on its nest? Could we come up with an experiment on our own? How could we do that?
Well, let's think about it. We could create an experiment, but we want to make the experiment so that it mimics what happens in real life. So let's consider a few things. I know when most organisms lay eggs, they lay more than one egg. So we're going to need a few eggs. Also, let's see, we need to mimic a bird sitting on the nest. How could we mimic a bird sitting on the nest? Do you think we could place something on top of it, maybe some books or something like that?
I think books would work.
For this experiment, you're going to need several, maybe 4 to 6 raw eggs. You'll also need a towel and 3 to 4 books. Anytime you do an experiment, it's important to keep safety in mind. It's always good to have an adult to help supervise the experiment, wear protective clothing, and protective eyewear. I also have a towel and disinfecting wipes just in case we break an egg. Dr. Knox, I think before we get started, it's a good practice to develop a hypothesis. What do you think?
I think so too. So let's think about what a hypothesis is. A hypothesis is a guess based on the information that we have now. So I wonder, how many books will it take to break our eggs? If it will. Let's think about that for a second. If I think about the size of a bird would weigh at least the size of one book. So I think it will at least hold one book. Maybe 2. What do you think, Miss St. John?
Well, I think that a bird is pretty small, but I think a chicken is considerably larger. So I think it's going to hold at least 2 books, maybe more.
All right, so let's try this and see. So I'm going to go through the experiment and go through it step by step. The first thing I'm going to do is I'm going to lay a towel down. Now, the reason I'm laying a towel down is to make sure that the eggs don't go rolling all over the place because we have a flat surface here. And also for protection in case we do break an egg. So we're going to lay our towel down. Then we're going to get 4 to 6 eggs. And I'm going to put them on the towel. And notice I'm going to lay them on their side. And I'm going to put them pretty close together. And I'm doing that because in an egg's nest, every time I've ever seen an egg's nest, I see that they're pretty compacted and they're close together. So next what we're going to do is place one book at a time on top of these eggs and see what happens. So after I place the book on the egg, we're going to stop and look and see if we notice anything. We ready to get started?
We're ready.
All right, so we have some pretty large books here. So we're going to start with this one. All right, let's look. Nothing so far. Whew.
That's a big book.
That is a big book. You ready for book number 2?
Ew.
Book number 2 is a little bit bigger. All right.
It's holding it.
It's holding it. It's still there. No eggs have broken so far.
So we've got 2 books.
We've got 2 books. Let's see how many, if we can get 3 before they break. Makes me a little nervous. Eggs are still safe.
It's almost chicken size.
It's almost. Let's see. Let's try the last one that I have. The eggs are still good. We've put 4 large books on tops of these eggs. Wow. So, was our hypothesis correct?
Our hypothesis was correct, but we added more books than you or I thought.
Yes. I wonder what makes these eggs so strong.
Well, I wonder if it has to do with the shape of the egg. Because I know the top of the egg, when you lay it sideways, has an arc on top. And I know that arcs are used in architecture and buildings, bridges, to make things stronger. In fact, I know that the building that we're in right now has a dome on the top. So I wonder if the dome shape And all of the eggs together are what is supporting the books.
I think that's a great thought, because I know we've talked a lot in math class about the different shapes and how each one of them has their own type of strength. And I've heard that arcs are strong as well. I've seen them in bridges. I know I see a lot of bridges with arcs on them as well. So very interesting. Well, Susie, I hope this book that Miss St. John read and our experiment has helped you learn more about eggs. And I would love to hear it if you come up with any questions that you had as we were reading the book or doing this experiment.
Well, Dr. Knox, guess what? I have another letter.
You have another letter? Great.
Yes, I have another letter, and I'm super excited. So let's see what it says. Dear Miss St. John, I have heard there's an experiment where you can remove the outer shell of an egg. Is that true? And if so, how does that work? Sincerely, Emmanuel. Well, Emmanuel, I have heard about this experiment, so we're going to try it out and see if it works. So for this experiment, you're going to need a few things. You're going to need a jar with a lid. You're going to need one egg, well, maybe more. Hopefully you won't break any. And you're going to need some vinegar. I have quite a bit of vinegar here. I'm going to need just enough to cover the egg. So, as we stated previously, when you're doing an experiment, you need some protective eyewear, something to cover your clothing, and you're going to need an adult to be with you when you're doing this experiment. So,
Well, Miss St. John, don't you think before we begin that we should create a hypothesis? We said that's a good thing to do, to think about our experiment and think about what we think might happen based on what we know. So if that's the case, what do you think is going to happen when we put the egg in the jar and we cover it with vinegar?
Well, I know that when I read the book, it said that the egg had pores that let air come through. But when I look at the egg, I don't see that. So I am interested in knowing what's going to happen to this egg. I don't know. Maybe it will be a little bit softer.
You think so? All right. So do you think that the vinegar will actually dissolve the eggshell?
Well, that's what we're going to find out. So that's what we're hoping to do. Now, I think it'll be a great thing to watch this and see what happens.
Okay, all right. I wonder how long it'll take. That's a question that I have.
Well, that's a good question. So we've got some math to do here.
All right.
All right, so the first thing I need to do is put the egg in the jar. Now, if you break the egg as you place it in the jar, you're going to need to rinse it out and get another egg. But mine slid in there nicely, so that's okay. Okay, so now I'm going to put the vinegar in the egg, in the jar, and cover the egg. I'm going to cover my egg completely up. Noticing it staying at the bottom. Okay. Do you think I have enough vinegar in there?
I think you do.
Okay. Okay, now I'm going to cover it up, and I'm going to place it in the refrigerator for about 24 hours. So about this time tomorrow, I can take this out, right?
That's right, but I'm already noticing something.
Oh, I'm noticing something too. Bubbles.
Bubbles. What do you think is causing the bubbles?
I think you guys can't see this very well, but there's all kinds of little bubbles that go on in here.
And the bubbles are all around the eggshell and they're going all the way to the top. Well, the bubbles occur for a couple of reasons. Well, first of all, an eggshell is made mostly of calcium carbonate. And although it appears that it's solid and hard, it can actually have as many as 17,000 pores, which are little tiny holes in them. And the acetic acid that's in the vinegar actually will go in and causes a chemical reaction with the calcium carbonate on the shell. And it breaks down that shell and causes it to dissolve. And what happens then is you end up with carbon dioxide bubbles that are coming up through here. So that's what that is. It's carbon dioxide being released and going to the top.
And it has not stopped.
Yeah.
It's still producing bubbles.
It's really interesting. Another interesting thing that I've read, and I haven't tried this, and I would really like to see if some of our students at home would try it and let us know about it, is I've heard that any acidic liquid, such as Coke, orange juice, or even rubbing alcohol, would do the same thing that this vinegar would do. But my question is this: would it do it at the same rate? Would some kind of liquid that's more acidic dissolve that shell faster than vinegar?
I think that sounds like something really fun to do.
I think it would be. We would love it if you would try that at home and then comment and let us know what you found out.
I would be interested in that. Okay, so I have this one, and I feel like I need to keep this one in the refrigerator for 24 hours.
Mm-hmm.
Okay, and so I'm going to put that one in the refrigerator for 24 hours. And then we'll come back and look at it again. Okay, so when we come back 24 hours later,
you will take
pour all the vinegar off.
Pour all the vinegar off. Be very careful with that egg when you pour that vinegar off. You're going to pour it all off. Be very careful because you're going to put more vinegar on the egg and put it back in the refrigerator for another 24 hours.
So, okay, we've got 2 days to wait on this.
Actually 3. We're going to do it 2 times.
Okay.
So we'll put the original vinegar in, put it in the refrigerator for the first 24 hours, take it out, rinse it off. And it's really interesting if you sit and write down what you notice at that point in time. One thing that I did when I did this experiment is I used a brown egg and a white egg. And it was really interesting to see the difference in what happened after those couple of days. Then you're going to rinse it off, put more vinegar in, and you're going to do that 2 more times. So it'll take you 3 days to completely do this experiment.
Great.
And on the 3rd day, what will you do, Miss St. John?
On the 3rd day, you're going to take the egg out, you're going to rinse it off, and you're going to make observations.
Well, I have some eggs here that we have already completed this experiment with. So let's see if we can make some observations. I had to keep them in water so they stayed moist. But I did it with 2 different eggs. So there's one egg, and there's the other egg. So what do you notice already, Miss St. John?
Well, I notice that the color has changed. I notice that the texture has changed. And I notice that the size has changed.
The size has changed. Why do you think the size changed?
Well, let's think about it. We put it in the jar with the vinegar, and we know that there are pores in there. So I feel like some of the vinegar has been absorbed into the egg. Is that correct?
That's absolutely correct. The outer membrane of this vinegar egg, which is very squishy now, it's really squishy, it's kind of fun. They're called bouncy eggs. The outer membrane is what's called semi-permeable, and that means that it only allows certain substances to enter. And in this case, it allows water to enter. So what happened is the outer membrane of this egg, of this vinegar egg, allowed the water molecules from the vinegar to enter in, and it made it bigger. And that's a process that we call osmosis.
Wow. That's a big word.
It is a big word. And so, and you can see that it happened in both of our eggs. Ooh, I can see, if you put it up to the light too, you can actually see the yolk.
It's floating around.
And it's floating around in there, so that's pretty neat. But you can see that it's considerably bigger. So you can see where the water.
Mm-hmm.
So what do you think about our hypotheses? Were they correct?
Well, I think they were correct. I think I learned a lot from that experiment.
I think I did too, but I think I have so many more questions.
You know what? We know that the water passed through, that the vinegar passed through the egg, and we know that the volume of the liquid of the vinegar changed. Or I'm guessing it changed. Is that correct?
Well, I don't know. I think that would be a good experiment for one of our students to do. If you at home are going to try this, it would be really great for you to measure the amount of vinegar that you put into the jar every night and note that down. And then when they pour it out at the end of every day, to measure how much vinegar was poured out and left. You know, another thing that I think would be really interesting for our students to do as well is I want to know if these eggs weigh different. Because if I'm feeling the two of these, it feels like this one weighs different. So it would be really great to have a student weigh this egg before they do the experiment and after they do the experiment to see about the difference.
I think that's a great experiment for someone to do because they look different, they feel different, and their sizes are different. So that would be something we would really need to know. I hope we've learned a lot through this experiment. And Manuel, I learned a lot doing your experiment, so I hope you learned a lot as well. And I hope you come up with some ideas for some more experiments as we go into the future.
Well, actually, Miss St. John, I have another letter from another student. Would you like to hear about it?
I would. We've got some students that have inquiring minds.
All right, so this student says, Dear Dr. Knox, would salt change the buoyancy of an object when it's added to water? Sincerely, Macy. Well, Macy, buoyancy is the force that's exerted on an object that is either partially or wholly immersed into a fluid. Basically what that means is whether it sinks or floats. So, let's see if we can develop an experiment to answer Macy's question.
Okay, well, you know, as we're developing an experiment, you're going to need to keep all the things the same except for one change. And the one change is going to be the salt. So as we think about this, we need to be sure that we are creating an experiment in a way that we are only testing for the effects of the salt. For this experiment, we're going to need 2 jars of the same size, same shape. We're going to need water, a measuring cup, a measuring spoon, an egg, and salt. As we stated before, anytime you're doing an experiment, it's important to keep safety in mind. It's always good to have an adult with you to help you supervise, to have your protective eyewear, and your protective clothing. Before we begin, let's think about our hypothesis.
Okay.
Okay, do you think there will be a change in whether the egg sinks or floats, sinks or doesn't sink?
Well, I know that when I add salt to water, it tastes differently. And I know when I add the salt to the water, it changes it, because salt water doesn't taste very good. So since it changes it, I'm going to go with something different is going to happen. I'm not quite sure what it is just yet, but I think something different is going to happen.
Well, okay, I think we can get started on this one. I've done this experiment, so I think this is going to be a good one for us to learn from.
All right, so let's begin. So the first thing we're going to do is we're going to lay our towel out. And notice that we have 2 jars here, same size, same shape. And we did that on purpose so that we make sure that we understand everything that's going on here. Now, something that you need to understand too is that there's a couple of factors that can affect buoyancy. One of those factors is the density of the fluid that you put it in. So we have to make sure, like Ms. St. John said, that we keep a lot of these elements the same. So we're going to make sure that we measure out the same amount of water for each one. That's why we also have the same size jars here that we're going to put them in. And the only thing that we're going to change is the salt in one of the waters. So, and the other factor that can affect this is gravity. And I don't know that we can do anything about that. So we're just going to make sure everything's the same. So here we go. So the first thing we're going to do is we are going to pour water into the jars. I'm going to put 1.5 cups into each jar. And I'm measuring that out using my measuring cup so I make sure that I am being consistent. Oh, no, that's one. We've got more water here. 1.5 cups water into each jar. I'm going to eyeball it to make sure, yep, I think we're pretty good. The second thing we're going to do is we're going to take, in one jar we're going to leave it just as water, because that way we'll know what happens when we do water. In the second jar we're going to put 5 tablespoons, tablespoons is the big one, of salt.
I'm noticing it looks different already.
It does look different, and I'm going to go ahead and stir that up a little bit. Okay? And the next thing we're going to do here is we are going to submerge the egg. Let's see what happens when we submerge it in the regular water first. What'd you notice, Miss St. John?
I noticed that it went to the bottom of the jar. And let me take another look. I do not notice that it's making any bubbles.
All right, so I'm going to fish, because we're going to use that same egg. So they're making sure that we're being consistent, and now we're going to put it in the salt water. What do you notice now, Miss St. John?
Well, I am noticing that it went in the jar, and I don't think you guys can see it really, but it did not sink all the way to the bottom.
It didn't all the way. It's floating some. So that makes me wonder if we need to add more salt to the jar. Maybe we need to stir it up a little better. But basically, here's what's going on, Macy. When you add the egg to this jar, the density of the egg is actually larger or greater than the density of the water, so it's going to make it float. When you add the salt to this jar, the density of the egg becomes greater, or the density of the water becomes greater than that of the egg, and so the egg floats. So, I think that's all we have for the day, Miss St. John.
Well, I think that it's been a really great experiment, and I've learned a lot from this.
Well, I would love to see it if any of our students did any of these experiments at home. So if you do any of these experiments, please feel free to tag us on Facebook and Twitter. On Facebook, it is Murfreesboro City Schools, and on Twitter, it's MCS Communicates. And we would love to hear what you found out, what results you had, and any questions that you might have. So hopefully you can go home and do these experiments yourself and have fun by doing it.
I would be really excited to see what everybody does with these experiments.
I
It's going to
would
be
too.
so much fun. So thank you guys.
All right,
Thank
have a
you.
good day.